for the technical difficulties. Okay, there we go. Um, Go ahead, answer our icebreaker for today. We'll kind of wait for everyone to trickle in. But yeah, so for today, what is your favorite fast food place? I think I have definitely been, I don't know, I like fall, mostly because this has a bunch of holidays and a bunch of good food. Um, not that, like I guess fast food is like okay, it's not particularly healthy, obviously, but sometimes it's nice to have fast food. Okay, let's see. Aldi says, I don't have one. I barely eat fast food. Okay, that's actually pretty valid. I think fast food has kind of died down. I used to eat it a lot as a kid, but then I realized like I like to like make meals at home, or I like when my parents cook because that's like more fun, I think, and it tastes better. Okay, Asha says Chick-fil-A or Dunkin'. Okay, I get Chick-fil-A a lot for like any high school conferences I go to because this is like the easiest thing to cater. So I would say I'm probably very tired of Chick-fil-A, but I think like if you don't eat it as often as I do, it's like pretty decent. Yeah, Dunkin' is great. Taco Bell. Yeah, I haven't been to Taco Bell in years now. Yeah, I think I also don't eat a lot of fast food, but yeah. Radhika says, does Chipotle count? Yeah, I would say Chipotle is fast food. Dora says Chipotle, awesome. And Chipotle. Okay, it seems like we have a lot of Chipotle. Oh, Tim Hortons. Is that like the Canadian thing? I think that's like the Canadian store. I don't know. Maybe. Yeah, it is. Okay, okay, awesome. Um, Bobbit says Qdoba. I think I had that at an airport once. But this is definitely not like Georgia. Like you don't really find this on like the East Coast, I think, or like the South. Amari says Papa John's if it counts. Okay, Papa John's is awesome. Yeah, they're the ones with the garlic sauce. Yes, yes, they are. Okay, yeah, that's what makes Papa John's pizza awesome. I like Papa John's and Domino's, but I do not like Pizza Hut very much. I don't know. I feel like their crust is too thick. Anyways, Popeyes as well. Oh, Popeyes is great. They have amazing chicken. It's wonderful. Let's see what else. Yeah, that is true. Even without the garlic sauce, it's great. Awesome, awesome. Oh yeah, Domino's is pretty good. I like Domino's like cold pizza. Like I like to have Domino's like the night before and then like eat it cold the next day, which I think is like kind of weird, but I think it tastes good. Oshrid says, I lived in Canada like 3 to 4 months ago. Oh, that is so cool. Wait, that's super duper neat. I hope you like Georgia, and I hope that everything here is awesome for you. Oh no, what did I do? I like messed something up. Oopsies. Okay, there we go. I fixed that. Stellar. Bobbit says, at least I think so. Awesome, awesome. Amrit says, oh, Panera Bread. Oh my gosh. I remember like when Panera Bread was like still super good and like had great value. Because my dad used to work near like a Panera Bread and he would bring Panera Bread every now and then. But yeah, I love Panera Bread. Subway, I definitely do not like. I find it easier to make a Subway at home. So, or a sub at home. Papa John's and Chipotle, fire, yeah. Oh, and Olive Garden. Yeah, I don't know if Olive Garden is fast food, but you know what? We can do restaurants too. Olive Garden. I like my goal is to like try to make the food from all my favorite restaurants. So like I loved Olive Garden, and so I tried to learn how to like make Italian food. And so now I can make like a lot of Olive Garden stuff at home, which I think is like pretty cool. I think it's pretty cool because now I don't have to go out if I'm craving like pasta or something. Velvet says there's no pizza without the Hut. But I disagree, Velvet. I think there are great pizzas without Pizza Hut. Okay, let's see. Okay, awesome. So, yeah, Tim Hortons, I think it's like more of a northeastern thing. Very interesting. Subway, awesome. Oh yeah, yeah, Panera Bread, broccoli cheddar soup. I heard that's pretty good. Oh, Taco Mac. Okay, I have definitely never been to Taco Mac. I find it easier to get a lot of like I'd say like Mexican cuisine. I find it easier to make that at home. So like Taco Bell, Taco Mac, I think it's easier to make at home than like buying it. I think I make a lot of fast food at home these days rather than buy it. Oh, Jimmy John's, yeah. I think I had Jimmy John's once and like I think it was 'cause like I don't know. I actually don't know why I had it, but I had it once. Okay. Oh no. Arby's. Oh yeah. I have never been to Arby's, but I heard they have good curly fries. Cool, cool, cool. Jason says everything. I think that's an awesome answer. Yeah, Olive Garden. Yay. Sachi says Papa John's. Awesome. Wow. Chick-fil-A from Rohan, Domino's from Saatchi, Papa John's from Sanvi. Okay, I think we've exhausted like all the good ones. I'd say I think my favorite is somewhere on here. Okay, well, anyways, this is really cool. I love talking about food. I could talk about food for ages. But anyways, let's go ahead and move on to some math for today. So, today we are going to be doing something very interesting, and hold on, once I minimize this. Okay, so for the past, I would honestly say like for the past month. Yeah, I feel like for the past month, we have been talking about quadratic equations, and we've done a lot of them, a lot with them. Like you guys have done some pretty impressive things in terms of um, I guess like quadratic formula, quadratic equations, Vieta's formulas, all those things. So today we're gonna kind of take a different approach. Instead of doing very much algebra, we're gonna do a little bit of graphing, a little bit of geometry, if you will. Yeah, okay, so let's kind of talk about, oh, let's recap. Okay, yeah, we can recap. So we talked about what a quadratic equation is. I'm sure you guys know what that is at this point. It's an equation of the form ax squared plus bx plus c is equal to 0. And so this portion on this side would be the quadratic formula, or sorry, the quadratic function. And then we'll have like this entire thing be the equation. So the equation is kind of like when it's equal to 0, and then like the quadratic function is like finding a y value. So it's kind of just like you don't equate it to anything and you just plug in different x values to get different y values. Okay, so this is like the quadratic equation, right? And so you can do a couple of things. You can find the roots, which is like our most important thing. And you can do this in a couple of ways. You can use the quadratic formula, which hopefully you guys remember, or you can do some factoring, or you can do some completing the square, which are all like good ways to find some roots. Okay, and then you can also, oh, and thank you, Ashrith, for putting in the quadratic formula there. We can also do some operations on these roots, and we will call those Vieta's formulas to simplify what those operations are. And so you can find the sum of the roots and the product of the roots. So this is kind of like what we've been talking about for the past month, basically. So today we'll kind of wrap up the topic by doing a good discussion on how to graph quadratics, because you can definitely see a lot from graphing quadratics. There's definitely some things there. So let's see, let's see. Okay, let's kind of do, you know what, let's just jump straight into it. So let me pull up, I think we should use GeoGebra today. Yes. Let's pull up GeoGebra and then we will, if I can do this, oopsies. Okay, hold on. I will stop sharing. And Desmos is good. I like Desmos, but I think Desmos sometimes can be harder to like show equations and stuff. Um, we actually, hmm, maybe we will use Desmos. Give me a moment while I figure this out. I'm like trying to think of the best tool. Um, yeah, let's use GeoGebra. I think GeoGebra is okay. Okay, stellar. So, let's go ahead and graph the equation. I'm gonna put in the equation here, and then I'm gonna share my screen so that way you guys can see like the equation that I want to talk about. Okay, amazing. Is there a way to hide it? Yes. Okay, so, oh no. All right, here's my thing. Oh man. Okay, share. Okay, stellar. So here's the equation I want you guys to graph. F of x is equal to x squared plus 2x minus 3. So that's what I want you guys to graph. Take a second, maybe I'll just kind of like zoom in so you guys can see some of the coordinates. And obviously it's a little hard to like share your graph, but once you guys have got a graph, go ahead and let me know in the chat. Ooh, and then I can annotate on this. Okay, wait, this is awesome. Okay, yes. Oh, this is so nice, you guys. but I don't like this color, and I want my line to be a little thicker. Okay, yeah, you absolutely can draw it online. I would recommend like, yeah, actually, I guess if you're drawing it online, that's okay. Uh, let's see. Yeah, I see a lot of you guys asking to use Desmos. I think GeoGebra can be a little better for this, so we'll go ahead and use GeoGebra for today. Yeah, both calculators are like really the same, so it's not a big deal. Yeah, so go ahead and graph this equation, x squared plus 2x minus 3. So you can graph this on like your own paper, drawing a grid. You can do it online. You can kind of figure out like some key points of this graph, and then we'll kind of go through it together. Okay, oh, Jason has given us some roots. So Jason says the roots are x is equal to, um, I think -1 and 2. Is that correct? Let's see. I don't think I would agree with that. I don't think I agree with that. Oh, wait. No, Jason says x is equal to -1 plus or minus 2. Okay, that makes more sense. So then that would be 1 and 3. Okay, yeah. So 1 and 3, I think. Um, all right, there should be a negative in there, -3. All right, let's see if that's correct. So we could do this as x minus 1, or yeah, x minus 1 times x plus 3. And yeah, that's equal to this equation up here. Okay, so cool. So these are our roots. I'll kind of like, here we go. Those are our roots. Amazing. Cool, cool, cool. Oh, so we all agree. Yeah. Okay, so I think a lot of you guys have figured out the roots. How many of you guys have got the graph going? How many of you guys have got a graph? Okay, yeah, so f of x is basically y. So this is like a function for us. Um, So we'll say like this is literally just like y. So you can say y is equal to x squared plus 2x minus 3. So this is like a quadratic function. The reason why it's not a quadratic equation is because we plug in different values of x to get y. If it was a quadratic equation, we would already know that the y is equal to 0, and that's why we solve for the roots. Okay, awesome. Anvika says, how do you find the vertex? A good question. Think back to one of the earliest strategies we learned for finding the roots. What is one of the first things we learned about how to find some roots? Ostrich says, how to graph a quadratic function as a curve. Yeah, go ahead and start trying out some values of x. So start putting in like x is equal to 0, 1, 2, -1, -2, and kind of see where that goes. And then think about how the line or how the curve would be formed. Like, what does the quadratic equation come out to be? Awesome. And then Ariel, if I'm mispronouncing your name, let me know. But Ariel, if you have any questions about what we're doing, feel free to message, and we'll kind of talk about this together. Yeah. Oh, Bobbit says the roots are the x-intercepts. Yes, that's a pretty key observation. So we know when y is equal to 0, right? That's what we solve for with the roots. So let's go ahead and jot down those points. We know that x is equal to 1 is one of those roots, and x is equal to -3. That's another one of those roots. So these two green points are on our curve for the quadratic equation. Okay? What's another point that's on the quadratic equation? Anyone have any thoughts? Go ahead and try plugging in any x value, any integer x value, and let me know what y value you get. So any x value counts. Okay, and Vika says the vertex is -4. The x-intercepts are -3 and 1. All right, yeah, let's go ahead and see if it's correct. I think this is something we'll kind of find as we finish the problem. So let's look at this one coordinate Audie has given us. So Audie has given us 2, 5. That means when we plug in x is equal to 2, we should get 2 squared plus 2 times 2 minus 3. Did I do something wrong? I feel like I wrote down the equation wrong. Uh, no, I didn't. Okay, so if we go ahead and simplify this, this will become 4 plus 4 minus 3, which is 5. Okay, amazing. So that means when we have x is equal to 2, the formula comes out to be, or the function comes out to return 5. So that means y is equal to 5. So when we graph this, we have x is equal to 2, y is equal to 5, and I realize now that I wrote this in the wrong place. So let's put a 5 over here. Okay, so that's definitely one point of our quadratic equation. What's another point that we can use? Oh, I should ask, what does the y-intercept do? So the y-intercept is when x is equal to 0. That's when the parabola or the curve intersects the y-axis. Yeah, so x-intercepts are the roots. The y-intercept is just when x is equal to 0. It's kind of like opposite. Okay, awesome. What's another point that we can try? What's another x value? How about someone gives me an x value and we can find the y value together? Okay, so Bobbitt says -1 is an x value. Yeah, so let's go ahead and try x is equal to -1. So when x is equal to, and I think I'll switch colors quickly here. So when x is equal to -1, oops. Okay, that means we have -1 squared plus 2 times -1 minus 3. And so this comes out to be 1 minus 2 minus 3. So what do we get when x is equal to -1? What does this come out to be? Yeah, -4. Perfect. So all we're doing here is just evaluating this, right? So 1 minus 2 minus 3 is -4. So what we did here was we plugged in x is equal to -1 into our quadratic function of x squared plus 2x minus 3. So when we did that, we figured out that y, our output, is equal to -4. So another point on our quadratic curve thing is going to be -1, -4. So if I graph -1, -4, this is kind of what I get. So let's go ahead and start connecting some points. I think we have enough points to start connecting. So I'm going to go ahead and draw a curve, and forgive me if I kind of mess this up a little because this is hard to do in one go. Okay, oops, hold on. Okay, so we get a little something that looks like this. Okay, what do we think of this? And here, I'll redraw kind of like the points we have found. So we found this point over here, we found this point over here, this point, and this point. What do you think of that? Oh, Tommy says -4, 5. Yeah, so this point that I've kind of drawn up here is actually -4, comma 5. Okay, amazing. Yeah, let's see, let's see. Some have no worries. We're so glad you're here. Yes, we are graphing quadratic functions right now. Yeah, awesome. Okay, Bobbit says they just use the graphing tool. And Bobbit, that's fine. But when you're taking a test or doing an exam, sometimes you won't always have a graphing tool. So it's important to understand like how we graph this and also figuring out some like notable points in this equation. Because sometimes you just can't rely on the graphing because sometimes you're not going to have it. Okay. Yes, draw it. Next time, draw it. Yeah, yeah, good question. Some has no. You can go ahead, draw it on your paper. That's all good. Yeah, I'm just on GeoGebra to show you guys, but you guys don't have to be on GeoGebra. You could just look at my screen. Okay, so I think let's do like a quick recap. Yeah, okay, let's do a quick recap because I think that would be helpful for everyone. So basically what we're doing here, we have this function, x squared plus 2x minus 3. Can you guys tell me like what a function is? Like what is a function? Go ahead and put your answer in the chat because I think that's probably where some of us are a little confused. So what is a function? I think like I introduced this definition when I introduced quadratic equations, but you guys have been working with functions since like the first day of this class. So you definitely know what it is. Um, but we've definitely talked about functions. It's just kind of been a while since I used the term. Okay. Let's see. Samhit says a rule with input and output. Adi says where one input equals exactly one output. Dora says a rule that assigns each input value to exactly one output value. Six Rules agrees. I think that's Nahal based on like previous trends, but I think that might be Nahal. Bobbitt says a function is an equation that gives a unique output for every input. Okay, awesome. And Anvika says something where the input results in an output and the input cannot have two inputs. Um, AS says input is equal to output. Awesome. Awesome. One input equals exactly one output. And Ariel says, I think a function is how it equals to an alpha. Okay, perfect, perfect. So good. You guys are all familiar with what a function is, right? It's basically like when you have some kind of like expression, some kind of rule, and you have an input. So we'll say you have an input, you put it through this rule and you get an output. So this arrow here is like our rule. This is like some operation, some expression that you perform on the input. So in this case, our rule, our function is equal to x squared plus 2x minus 3. Now, our input is x, our output is the value of this expression. Is that clear to everyone? Yes. Okay, lovely. So basically what we're doing when we want to graph, we have x values and y values. So we're taking x values, we're plugging them in into our function, and then we're finding a y. And that's exactly what Jason says. Jason says you can give an x and then you can find a y based on that. So what we have been doing for the past few minutes is we've been looking at different x values, like x is equal to 2 and x is equal to -1, and even like x is equal to 1 and 3. And we plotted all of those points on our graph based on what the rule tells us. And so once we have a good idea of like where these points are, I went ahead and connected all of them on the smooth curve. Okay? So this is kind of like what the quadratic equation does. Something interesting to note is, let's say, okay, so that's kind of like what this f of x thing is. This is like f is the function, and so hold on, I should write this. Okay, so I have f of x, right? And so we'll say like this is equal to y. So f is my function. X is equal to my input, and y is my output. Okay, so I have f is my function, x is my input, and y is my output. So I'm taking my function rule and I'm plugging in the x value, and then I'm getting a y value. Now this might seem like complicated, but you guys have been working with functions since like day one. When we did like y's, or hold on, let me get rid of this yellow color. I know sometimes that's hard to see. When we did like y is equal to 7 minus x, that's a function. That's a function because you have an input and you have an output. Okay? And so quadratic functions are the same thing, except you just have an x squared. So x squared plus 2x minus 3 is still a function, and we can write it as y is equal to x squared plus 2x minus 3. Okay? And so all we're doing here is we're taking different x values to get different y values. So when I have x is equal to 2, we found that y is equal to 5. That's what this thing down here is. That's what this work is here. When I had x is equal to -1, we found that y is equal to -4. That's this function over here. Now, we also solve for what happens when x is equal to 1. That just comes out to be 0. And that's just finding the roots, which you guys know. So all we're doing here is saying like y is equal to 0, and then solving for x squared plus 2x minus 3 is equal to 0. So the roots, or the solutions of this function, are y is equal to 0, like when y is equal to 0, or f of x is equal to 0. Okay, so this is like our roots. Um, Okay, and then that's kind of like where all these points come from. So let's pause here. I think this is kind of like a lot. None of this is like new stuff. We have either talked about it or like implicitly discussed it. So really all we're doing here is like putting some fancy like terminology around all of this stuff. But yeah, you guys have seen this before, so don't be too intimidated. Okay, let me also like look super quickly at the chat and see how everyone is doing. Ashad says, so I can use a random number to place or plot. Yes, any number you pick for x will fall along this curve. Also, if it's not clear, this curve like goes on forever. Like it doesn't stop at this point. It kind of like goes on forever. And so we draw some arrows to represent that. Also, this curve is supposed to be smoother than I've drawn it. It's not supposed to be very sharp, but it's kind of hard to draw. Um, okay. Thank you, Jason, for putting that image in the chat. That's helpful. Um, okay, awesome. Okay, Asha says, so function is all the answers as a variable. I th- I think you kind of have it. Yeah, so basically like what we're saying is we're saying we have this function f, we put some input x, and when we perform the function on this input, we get this output. Okay? And so all we're doing here is we're taking different x values to get a y value. So we're just evaluating this function at a specific x value. So that's it. Yeah, this is I definitely know this is like eighth grade stuff for sure, like eighth grade math. So no worries if this is hard. And Anviti, yes, I'm about to go ahead and plot it once everyone is on the same page. But yeah, thanks for thinking ahead. Okay. Oshert says, would the input be the root? No. So the root is just the specific value that gives you like y is equal to 0. So the root is the value that gives you an output of 0. In this case, if we have x is equal to -1, that gives us 0. That's just the root. And x is equal to -3 also gives us 0. That's the root as well. Okay? So roots give us an output of 0. Okay, awesome, awesome. Okay, cool, cool, cool. Amazing. All right, so let me go ahead and show you guys the graph. I think maybe that will help a little bit. So I'm gonna go ahead and click this over here. And okay, I don't know if you guys can see this. Can you guys see this like, oh, wait, I like totally ruined it. Oopsies. Okay, can you guys see this like green line over here? I'm like kind of outlining it. Is that like visible to everyone? Yes. Okay. So that like green line, and you can kind of see it like up here. Maybe I'll like, oh, wait, I definitely can't move this. Oh man. Okay, that's fine. So there's kind of like a green line up here. There's kind of like a green line up here, a green line over here. So this green line is exactly like how this function would be graphed. And so that's kind of all we're doing here. We're just graphing this function, and it turns out we get this like rounded cone shape kind of thing. And this is what we call a parabola. How many of you guys have heard of this term? Yeah, a smiley, but it's very like, oh, it's very like stretched, I feel. It's not, I don't know if this is like a true smiley face. But you can definitely like extend it like wider to make it a smiley face for sure. Yeah, so this is a parabola. And let me see if I can make this a little more visible. Um, color. Sorry, this might be like oh, wait, I don't want to use green because I just use green. I'll use like this color. Okay, I think that's a little more visible. If you guys can see that like yeah, that super like blue line, super bright blue line, that's where our curve is. Uh, and so you can kind of see like even though I drew this like very rough sketch, I was still able to get it like pretty close to like this actual parabola. Okay? All right, so let's talk. How do you guys feel about this now? Is this a little bit more clear, like what we're doing? Basically, all we're doing is we're just taking different x values, plugging them into this function, and getting out different y values. And then we're just kind of like drawing a smooth curve like that. Okay? Yeah, it kind of does look like a half egg for sure. Okay, any questions so far? We'll keep doing some more practice if you guys want to build on this. But otherwise, we'll go ahead and move on. Okay. Yeah, it is a long egg. How do you find the vertex? Good question, Oshrit. So the vertex is like kind of the pointy bit down here. So in this case, Anviti actually gave us the vertex a little earlier. Um, oh man, okay, sorry. So the vertex is going to be this -1 comma 4, or -1 comma -4. Now, how do I know this is exactly the vertex? Because what's interesting about the vertex is it's the only value, it's the only y value that is achieved once. So if you kind of look at this graph, you can see every y value kind of gets met twice. Once on the left side of the parabola and once on the right side. But at the very, very bottom of the parabola, at the very tip of the parabola, we see that the y value is only reached one time. So there's only one x value to get -4. There's no other x value that you can plug in to this formula to get -4. However, like let's say we were looking at 0, right? When y is equal to 0, we have two different x values we can use. Or when y is equal to 5, we again have two different x values. We have x is equal to 2, and we have y is equal to negative, or x is equal to -4. And both of these give us a y value of 5. Yeah, like how do you know it's -1, 4? For that, I encourage you to maybe take a look at completing the square. And we'll talk about this kind of going forward, actually. So this is kind of what we're going to be focusing on next. But I will give you guys a hint. Think about completing the square. Okay? Well, on that note, let's go ahead and take a look at one next question. I'm going to go ahead and clear my screen if no one has any questions. Are we all good, everyone? Yes, yes. Okay, stellar. So let's go ahead and kind of clean up this page. Oh, oops. I don't really like use this annotate tool a lot, so this is like definitely new for me. Okay. Amazing. All right. I'm gonna go ahead and do another one. This time I'll do like y is equal to, so that way it's a little more clear. Um, x squared. Oh, I don't want this like, okay. Minus 4x plus 3. Okay, amazing. So this is our next thing. Y is equal to x squared minus 4x plus 3. Amazing. Bhavit asks, can we graph a square root function? I think we still need a little more practice with quadratics, but maybe if we have time, we can look at the square root function. Okay, awesome. So let's go ahead and start graphing some key points, and then we kind of could see like what this graph looks like. Yeah, so if you guys want to go ahead and graph this on your own first, and then let me know in the chat when you think you have a good diagram, and then we'll kind of go ahead and start looking at some different points together. So I'll wait a couple of seconds for you guys to go ahead and draw a graph. If you guys are not drawing a graph, that's what you should be doing. And then we'll go ahead and talk about how to finish up this problem. How do you draw on GeoGebra? Do not use GeoGebra to draw your graphs, guys. Draw your graphs on paper. Draw like a grid or something, and then draw your graphs on paper. Yeah, yeah, yeah. Don't make a graph on GeoGebra. That defeats the entire purpose of graphing. Okay. Oshrid says, are the roots -3 and -1? Yes, 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 they are. No, okay, Oshrid, you're really, really close. Check your signs. Check your signs on the roots, but you're super close. Yeah, Adi has got it. It's 3 and 1. Yeah, yeah, yeah. Check your signs. Okay, awesome. Yes. Okay, so the roots 3 and 1 are absolutely correct, right? So let's go ahead and actually draw these roots. I feel like I haven't used this dark blue yet. Um, so let's say like y is equal to 0 means that x squared minus 4x plus 3 is equal to 0. And like Audie says, you can get this just by factoring. You have x minus 3 times x minus 1 is equal to 0. That means our roots are x is equal to 1 comma 3. Okay? And so we know that when x is equal to 1, y is equal to 0. So we have this point is on our curve for sure. And when x is equal to 3, y is also equal to 0. So you have this point on our curve for sure as well. Okay, really interesting. And let me kind of like move the page over a tad. So that way, like, I feel like we're gonna be kind of okay, that's fine. All right, amazing. So we kind of have 2 points already. I think we need a couple more though. So go ahead. What's an x value we can try out? What's another x value? Okay. Anvika says we can try x is equal to 2. So when, oopsies. Okay. And for this one, I will do like this orange. So when x is equal to 2, we have um, y is equal to 2 squared minus 4 times 2 plus 3. So what does this evaluate to? What is 2 squared minus 4 times 2 plus 3? And while you guys are solving that, Oshrit has a question. How do you draw the curve if you don't know the vertex? Well, you can go ahead and try some different points out, and you'll kind of find the curve or find the vertex from there. But yeah, we'll talk about how to find the vertex, Oshrit. Yeah, don't worry. Um, cool. So everyone says to try. Okay, yeah. So Bhavit says -1. Amazing. Audie says it is the opposite than the sign in the factoring. Yes, thanks, Audie, for that um, point. Okay, yeah, I think some have clarified that when you're factoring, you make sure to solve for x. So not necessarily opposite sign, but solve for x. Okay, amazing. Cool. So everyone is saying -1. Okay, cool, cool, cool. So we'll have 2 and -1. So this is our other point. Okay. And I see a lot of you guys kind of talking about maybe how to find the vertex. Don't worry, we will get to a proof in a second. So don't just memorize that it's the midpoint of the roots of the x. You can, there's a reason why it's so. And that's what we're going to talk about. I always say don't memorize. So hold off on a second. Like it's okay if you don't know how to find it yet. Like we'll talk about it. Yeah. Okay. Cool. Cool, cool, cool. Okay. I think. Yeah, I think, okay, let's do a couple more points. Guys, don't worry about finding the vertex right now. I just want to make sure you have this graph. I think everyone is like super concerned about finding a vertex. We will prove it in like 5 minutes. So like, don't stress, okay? Um, all right, let's go ahead and look for some other points. So Audie says we can try x is equal to 0. Yeah, and I like that because x is equal to 0 is when we have a y-intercept. So that's just this like constant term over here. So let's say this point is definitely on our parabola. What's another point without our parabola? What's another point on our parabola? Yeah, and Vika says 4, 3. That's really good. I like 4, 3 as well because that's the other point where we can get an output of 3. And you guys can verify that for yourselves to see why that's true. Okay. Um, cool, cool, cool. Okay. Amniti says, can we graph without the vertex? Just a genuine question. It is possible, like if you understand like how a parabola is like how a parabola works, you can kind of like get the vertex without solving for it. Like you will draw your parabola in a way that it passes through the vertex, even if you haven't already solved for it, if you understand like how the parabola is shaped. I think it's easier to actually find the vertex, like that guarantees you're getting the right shape. But yeah, we'll talk about that, you guys. We'll talk about how to find a vertex. Don't worry. Like I have it, it's in the plans. Okay. Yeah, and 4, 3 works as well. Some has says 0, -1. Some has check your work because if y is or if x is equal to 0, we should get y is equal to 3, not -1. Um, okay. Ostrich says, what is the -1 used for? And what is the yellow step and do we need it? Yeah, yeah, yeah. Okay. So I think you're referring to this orange. It's orange on my screen. Maybe it shows up like yellow on your screen. So this step is just like we're just doing it to find another point. So that's like kind of all it is. So this orange step we actually have plotted right here. So that's like this point that I've circled here. Okay. Um, and VT says, so like patterns in the parabola. Yes, 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 yes. That's absolutely correct, NVT. Okay, Samhith says, wait, yes. Ask a question, Samhith. Um, 0 squared. Samhith, check your work. I think you are thinking that -4 times 0 is -4. Remember, that's going to be 0 plus 0 plus 3, which comes out to be 3. Okay? Yeah. Okay. No, no, it's all good. Sometimes we all make mistakes. So let's say x is equal to 0, right? Because I think some people want to see this written out. So then we get y is equal to 0 squared minus 4 times 0 plus 3. So this is 0 minus 0 plus 3 is equal to 3. We can also say x is equal to 4. Then we have y is equal to 4 squared minus 4 times 4 plus 3. And so in this case, we again have y is equal to 3. Okay, so we have 0, 3, and 4, 3 are also points in our parabola. Alrighty. How do we all feel about this? Where did you randomly choose these numbers? Yeah, so I actually just chose like consecutive numbers. So if you notice, like I've just chosen like x is equal to 0, x is equal to 1, x is equal to 2, x is equal to 3, and x is equal to 4. So these are all kind of like in order. Yeah. So I just want to choose, like, my only restriction is just to choose integers. Like, that's really all that matters. One thing that helps is I know what the roots are. And so I picked values that were kind of around these roots. So I looked at the value in between, that was 2. And I also looked at a value less than and greater than both of these roots. Okay, does that make more sense to everyone? How do the roots help and beat the s? Yeah, so the roots kind of tell us like first of all, it kind of like guides us to figure out like where our parabola is like kind of centered around the graph, and also like it gives us some pretty important points of like where this parabola like intercepts the x-axis. And intercepts are always super helpful in graphing. Okay. Cool. So, are you guys good? Okay, actually, let me go ahead and show the graph and then we'll kind of talk about some other things. So, here's the graph and notice how it goes exactly through these points. Okay? So, exactly through these points. So, this is pretty interesting. Um, Okay, I think I saw a question. Okay, I see a lot of spam in the chat, which is kind of like preventing me from seeing all the questions. And I think this is starting to get a little tricky for everyone, the concept-wise. So let's go ahead, make sure we're toning it down in terms of spam, so that way we can answer everyone's questions and make sure everyone's clear on the topic. Okay, I see a question on what do the roots represent in a parabola? It represents where the parabola intersects the x-axis. So remember, the parabola is just like y. This is literally like the function y. Like it's just y. And so remember, we said roots are when y is equal to 0. That's when this entire equation is equal to 0. And so in that case, we have these x-intercepts. So the roots, the meaning of the roots have not changed. We're just putting them in graphical form here. Okay, and if this is a little hard to see, I'll go ahead and change it. Oh, oopsies. I'll go ahead and change it super quickly. Do like a green. Okay, amazing. Okay, hopefully that's a little better for everyone. Um, okay. Let me double check for questions again. Okay, Ashit says if I do x is equal to 1, I get 0. That is correct. Yeah, Asher, that's correct. Remember, x is equal to 1 is one of our roots. So we say we're one coordinate on the x-axis and zero coordinates on the y-axis. So that's this point over here. Yeah, you've done that absolutely correct. Okay, Anviti, no problem. I'm glad we got that cleared up. Okay, awesome. Okay, I see another question. So inserting the random numbers at x in a formula that gives us what? Yeah. So we can basically plug in a bunch of different values for x and get a bunch of different values of y as the output. And when we connect all of the dots between like all the x, y coordinate pairs, we get the shape of a parabola, which is kind of like an egg. Okay, so I think we now have to answer the very burning question that you all have about like, how do we find this vertex? That is not an egg, Oshrit says. Yeah, I guess it's like a weird lopsided egg. Yeah, parabolas are kind of like a weird shape to find. Okay, Jason says, can't you find the y-intercept faster? You can find the y-intercept, but you can't really graph much with it because the y-intercept is like just this constant. So like that doesn't really tell you much about the parabola because you can just shift it up and down. So like it's not super duper helpful, I'd say. Okay, so let's go ahead and talk about finding the vertex because I think a lot of you guys had questions about this, so let's answer them. Basically, the vertex is like a pretty key part of the parabola. And if you have the vertex and the roots, you can find out the entire parabola based on that. Okay, so let's see. I want to make sure I explain this really clearly because it seems like this is like something pretty big for you guys. Okay, so we'll go ahead and do completing the square. I think I hinted at this earlier, but I don't think anyone like actually executed it, which is okay. So let's go ahead, pull out our thinking completing the square. I know this was like super tedious when we first did it. Hopefully it's gotten easier for you guys. So go ahead and complete the square for x squared minus 4x plus 3. And remember, think about what completing the square is. We're basically rewriting this in the form x minus something, I'll put this as like a question mark, squared plus something over here. Okay, so think about like what goes in these spaces. And I would also say, think about the magic number. This is kind of where we introduce like magic numbers. So think about that and go ahead and see if you can complete the square. I'll give you guys a couple seconds for that. Okay. Azara says, how did I get x minus 3 times x minus 1? I just did some factoring here. We can kind of do this by observation. You can also see, like, based on completing the square, like, why this is the correct factoring. But yeah. Okay, Bobbitt and Nahal say 2. Okay, yeah, so I think 2 is, like, what goes in this first question mark. So let me go ahead and, like, write that. So we get x minus 2 squared. Okay, that's perfect. So what do we have to, like, do over here to balance this entire equation? What do you guys think? Okay, Audie says x minus 2 squared minus 1, and I think I agree with that, Audie. Okay, so let's talk about why this is. Um, okay, negative 1, amazing. So subtract 1. Okay, perfect, perfect. Yeah, thank you guys all so much for putting that in the chat. Okay. Yes, like Audie says, let's stop spamming. I got it the first time you all said it. Okay, amazing. Yeah, so we have x minus 2 whole squared minus 1. Is everyone clear on why this is like the completing the square version of this? I think we talked a lot about completing the square, but I just want to make sure like we're all on the same page here. Okay, yes, everyone understands this. All right. Amazing. So I think a lot of you guys are already starting to see like where this is coming from, right? And so if we take a look, remember what I said about the vertex? The vertex is the only point on the parabola that can be achieved by exactly one x value. So, oh, Anvita says, I don't understand, please help. Yeah. So when we did completing the square, we basically found like a magic number, which actually just ended up being half of this coefficient here. So if this is -4, our magic number is -2. So then we have x minus 2 whole squared. So when we expand x minus 2 whole squared, this is like our square thingy, right? This is the square part of completing the square. So we get x squared minus 4x plus 4. And then to balance it out to x squared minus 4x plus 3, we have to subtract 1. And so this now equals this. So that's how we get this. If you are unfamiliar with completing the square, I recommend you rewatch the lesson on this because we go pretty in depth into it. Okay, great. So let's return back to our question. And I think a lot of you guys are now seeing like how the vertex is related to completing the square. So hopefully that's like super clear, but just to kind of finish it up, the vertex is basically like the one point in the entire parabola that has exactly one x input. Remember, in all other places in the parabola, you can get every y output by using two different x inputs. So two different x inputs can give the same y output in the case of this parabola, except for when you're kind of dealing with this bottom vertex here. And so this bottom vertex is going to be the place where when x is equal to 2, so x is equal to 2 and y is equal to -1. And the reason why I say 2 is because this factor then becomes 0. And there's only one way to get 0. If we had instead said something like x, like if we had said like, let's say like x minus 2 is equal to, like x minus 2 squared is equal to 4. Well, I don't want to do 4. Let's say like 9, right? Then x could be equal to 5 or x could be equal to -1. But if I had said x minus 2 squared is equal to 0, then x has to equal 2. Now, why is that? Because when I take the square root of 9, I can either have x minus 2 is equal to 3, or x minus 2 is equal to -3. So I have two different values here. But if I take the square root of 0, I only have 0. There's not two different like square roots of 0. There's only one. And so that's why the vertex occurs at the point where this square portion is equal to 0. In other words, x minus 2 is equal to 0, so x is equal to 2. And when x is equal to 2, that means that y has to equal -1. And so this point is our vertex, and you can see that here as well. Okay, so I'm going to pause here, take a quick look at the chat. Um, Hold on. I think I missed some of your comments because I just wanted to like get this out. But yeah, okay. Jason says, is the midpoint as a x in between the x-intercept? Yes. Yeah, Jason, that's actually a great way to summarize it. I think someone said this before. I think Anvita said it before. Yeah. Okay. Cool. Okay, MVT says, what is the point of manipulating the function like this, like for completing the square? Okay, so the reason why we want to write it like this is because we can kind of like figure out at this point where this is kind of just like our vertex form, essentially. And when we complete the square, we kind of figure out like um, we can kind of get closer to figuring out like where this x value is or where a certain y value is achieved only once. So we can get closer to figuring out like how to make this 0. Yeah, this is definitely a lot. The key point is we're just applying completing the square and then just talking about it in graph form. So yeah, but I will definitely recap. Ashraf asks, isn't finding the midpoints of the x-intercept, then substituting it into the equation an easier way to find the vertex? Yes, that's true. I just want to show you guys like how the vertex like relates to completing the square because this is like still an important connection. But you can find like the vertex by averaging the x-intercepts or the roots. I think that's how a lot of people have done it. Yeah. Okay. I think Sumhith has kind of summarized like why sometimes it's useful to look at completing a square. So yeah, thank you, Sumhith, for that. Um, Okay, cool. So let's kind of like recap, and I think this will make a little more sense. Okay, so basically what we're doing is we are trying to find like the highest or lowest point. So like that's what the vertex is, right? It's like the you kind of like are going like in this case you're kind of like going down, 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 down. You get to that very lowest point. Only one x value can get to that point, and then suddenly you start going up, 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 and you start passing the same points you have just went down. Okay, so that's like what a parabola is. It's like going down and then going up. And that's what it looks like in this case. And so the vertex is going to be kind of like the highest or lowest point. Because our parabola kind of looks like a bowl shape, it's going to be the lowest point on our parabola. Okay? And so we want to show like this x coordinate or this vertex is equal to like negative b over 2a. And I think a lot of you guys have already reached this conclusion yourself, but that's like formalizing what we are trying to do. Okay? So one way to do this is looking at completing the square. And the reason why that is because when we complete the square, remember to find our magic number, we had to divide this b value by 2. And so that kind of relates to like x is equal to negative b over 2a. Okay? So we do this like completing the square business. We do all that jazz. And then we get to like this form, right? We got 2. Hold on. I'm trying to find some space to write it. I'll write it inside the parabola. Okay, we go to y is equal to 1 times x minus 2 squared minus 1. And so this is what is known as vertex form because we can immediately say the vertex is going to be 2, negative 1. We're just looking at this and this part here. We're looking at for whatever makes this 0, that's going to be our x coordinate, and the result of that is going to be this constant out here as our y coordinate. Okay, so as you can see, when we do this completing the square business, x is equal to negative b over 2a. Okay, all right, and so this kind of like occurs. So this like lowest value occurs at this x value because when we have x is equal to negative b over 2a, regardless of what x value gets plugged in, it will always be greater than this y value. Okay, awesome. All right, I'm glad that helped you in VT. I'm glad that was helpful. Um, okay, awesome. And then, yeah, another way you can kind of do this is like I guess like yeah, and then the other way I think it can be a little easier sometimes is finding these vertexes or these roots and then taking the midpoint. Interestingly enough, it doesn't just have to be the roots that is this value. You can also look at any points that have the same output. And if you take the midpoint of their x values, you get to the vertex. And so that's why if you draw a line through the vertex, okay, this diagram is getting really crowded, so I'm gonna like erase some things. Okay, so if you like kind of draw a line through the vertex, see if I can do this. Oh, that was horrible. Oh my goodness. Oh, is there no way to like draw a straight line on here? This is really silly. Okay, here we go. Okay, so we draw this straight line, right? And if we flip the parabola across this line, it's the same thing. So like what I mean to say is like if you flip the 0, 3 point over to this across this axis, you get 4, 3. If you flip 0 or 1, 0 across the axis, you get 3, 0. So we call this axis the axis of symmetry because this is like the line that splits the parabola in half, and anything reflected across the axis like is on the parabola. Okay, amazing. Okay, cool, cool, cool. And so that's why like anytime you have the same y value, you can take the average of those endpoints, the average of those x values, to figure out like what the x value of the midpoint is. Okay? Amazing. So in general, when we want to graph, and I know we're at that 9 o'clock mark, so I'll go ahead and wrap it up super quick. In general, when we want to graph, we want to first find out the roots. Then we want to find out the vertex, so like the midpoint of those roots. And then we kind of want to figure out like the y-intercept. So where does this parabola intercept the y-axis? And then based on that, we can kind of plot a couple more points, and then we have our graph. Okay, so that's kind of like a summary of how to graph quadratics, and that's kind of like a summary of what we've all talked about today. So like what all the tools are that we talked about today. And I think this will kind of wrap up our unit on quadratic equations. I know this is definitely a lot. We basically covered like a semester of eighth grade math in like a month. So there's definitely a lot going on here. But if you have questions, definitely feel free to ask. And I think we'll do like one more unit on absolute values and we'll kind of transition to number theory after that. But if you guys have extra questions or extra topics you want to cover in algebra, feel free to shoot me an email or a message so that way we can definitely cover that because I want to make sure we're covering content that you guys are interested in. And then, yeah, so we'll be talking about number theory shortly and the world of algebra will be gone. But okay, amazing. So thank you all so much for joining me. If you have questions, feel free to stick around. Otherwise, I will see you all next week. Bye, everyone. Thank you so much for joining. Amazing. Bye, Anviti. Bye, Audie. Bye, Tharuv. Thank you. Bye, Vishit. Bye, Vahi. Bye, Anviti. Amazing. Bye, Jason. Thank you. Bye, Audie. Bye, Rohan. Bye, Bhavit. Bye, Samhit. Asha says, do you do trial and error to complete the square? No. So when we complete the square, we're trying to get it into this x minus 2 squared, or we're trying to get it into like the form plus b. So this is the form we're trying to get it into. And so when we complete the square, we can pretty easily find like this a value because it's just half of the second term in the quadratic. So in this case, it would be half of this term. And so we would get x minus 2 squared. Okay, so that's kind of how that works. We have a video on that on our YouTube channel, like covering all of completing the square. So I would recommend you check that out. Yeah. Okay, bye Nahal. Thanks so much for joining. Yeah, bye Anvika. Bye Amari. Thank you, thank you. Bye Tanvi. Yeah, bye Sanvi. Oh yeah. Yes. Ashrith, go ahead and unmute. Yeah. Um, Nahal, the channel is just like Bridge2Math. Like it's literally just like the organization name. Yeah. Go ahead, Ashrith.
Um, so you know how the vortex in this case is 2 comma negative 1?
Yes.
So someone in the chat told me this. I don't know if it's true or not. I can find the roots of the quadratic formula, then take the midpoint of them, which gives me 2. And then I put that into the x part of the function, and then that will give me the y, and that's my vortex.
Yeah, that's absolutely correct. Now, the reason why I didn't like say anything about that before was because I wanted you to understand like why that's true. And that's kind of what we've proved here, right? We found this axis of symmetry, which helps us show that anything like across this axis is similar, right? So I have like this point 1, 0 here, and hold on, I'll go ahead and label that. So I have like 1, 0, and I have 3, 0 here. And so my axis is going to be right in the middle of these 2 points. That's how I'm able to reflect and get the same value. So to find this exact middle point, I'm just going to take the average of my x coordinates. And so in this case, I find out like x is equal to 2. And so when x is equal to 2, I plug that into my initial like quadratic function up here, and then I figure out that y is equal to 1. And so that's what's going to be my vertex. Okay?
Okay, yeah.
Amazing. So does that like make sense why you take the midpoint?
Yeah, and then to draw the curve,
Yes.
it, so I just put a random number. Like I usually go in order, and I skip the roots.
So I would say like you can find the roots and find the vertex, and then I would probably suggest finding the y-intercept. And once you have that, you have enough points to like draw a curve.
Okay.
Yeah.
Oh, so when I give it the x, oh, I just got it. When I put
Okay.
the x number in, it gives me the y number, and that's how you got the blue dots.
Yes, that's absolutely correct. Amazing.
Okay, yeah, I got it.
Good work.
When will
Okay.
the homework be sent? I put it
Um,
last time.
oh, you didn't get it. Can you give me your email? Because I want to make sure you're getting everything. If you want to put your email in the chat, I'll go
Yeah,
ahead and make sure you're in the list.
one sec.
Yeah, of course. Take your time. Okay, perfect. And so you will access the homework from there. And yeah, okay, so you'll get the homework, you'll get access to the recordings and everything, and so
Can
you
you
can
send me
see.
the Zoom meeting to there too? Because the
Yes.
other one's my dad's, and I have to go there and forward it every time.
Okay, yes, I can send it as well. Absolutely. All right, amazing. Thank you,
Yeah.
Ashworth. If you have any questions, feel free to reach out. All
Okay,
right,
sure. Bye.
bye. Amazing.